Have your textbooks open at page 104 and have your homework out, if you would please. UDIT, pages 104 to 105, numbers 14 through 20, the even, as well as 28 to 38, the even. So we skipped over 22, 24, 26 because we'd already done those, but otherwise 14 to 38, the even, if you would have those out so that I can come by and check. Excellent. I did my work in the book. Alright, sort of, kind of ish. Alright. You just are very concise in your work, right?
Who, Kendall or me?
You.
Yeah.
Alright, let's go and review some things we talked about recently. We've talked about numbers that they do exist. I mean, it's not that they don't exist. They have a rough name, though, makes them seem like they don't exist, class. But really, all an imaginary number is a square root of a negative value. And the most basic square of a negative would be the square root of negative 1, which we call I. And we have 4 fundamental powers of I, class. I, the first is I squared is, that's an important one, negative 1. I cubed, negative I. Genesis is covering her eyes. All right, and I, the fourth is 1. And so anything bigger than that, remember, we said we just take 4 i's out, or as many 4 i's as we can, and whatever we're left with will be one of those fundamental powers. If it's not, you can take out another 4. And eventually you get one of those fundamental powers, and you would have any power of I simplified. We said the key to working with imaginary numbers, anytime you see the square root of a negative, Kendall, is to take out the I, or pull out the I, rip out the I, gouge out the I, however you want to put it. So if I had the square root of negative 18, the very first thing I would do, Kendall, is
pull out the I.
And this becomes an I times the square root of 18. Of course, we can further simplify this radical.
9 and 2.
Factor into 9 times 2 so that we get
3. So 3i times the square root of 2.
3i times the square root of 2. We happen to have the square root of negative 6 times the square root of negative 8. What's the first thing I would have to do here, Maddie? So, there we go. Pull out the i's to get I squared of 6 and I squared of 8. Then from there we can multiply, Audrey. Of course, we know anytime we see an I squared, Brandon, that just means negative 1. And then the square root of the 48, we can factor how, Abby?
16 and 3.
Of course, out of the 16 Genesis, we can pull out a 4 times the negative 1 that was already out here gives us negative 4 times the square root of 3. If I were to have the square root of a negative 12 added to, say, the square root of a negative 27, what would I have to do here, Michael?
Pull out your i's.
And what does that give me?
That gives you I square root of 12 plus I square root of 27.
Good. And if we wanted to, I suppose we could do the factoring at the same time. We pull out the i's. For instance, we factored the 12 into
4 and 3.
So instead of just pulling out the I, let's also pull out a 2 with it to get
2i square root of 3.
Good. There's the 2. There's the I. And I'm not sure why I wrote a 2. You said square root of 3. And over here,
you can pull out a 9 to get 3i square root of 3.
And we can add these together just like we would add anything together. They're like terms. They're also like radicals. What would we get for our answer, Kendall?
5i times square root of 3.
There we go. Remember doing all of this. This was a little bit different than maybe what was in the homework in some cases. Questions on this? All right, let's take a look at the homework now, page 104. Number 14, you are adding numbers that you can see some real portions in there, but you also see some imaginary portions. What do we call numbers that are part real, part imaginary, Maddie? Complex numbers. And the standard form of a complex number, Abby, could be written how?
It's the real number and then the imaginary.
Yeah, what's that form I told you?
A plus bi.
There we go, A plus bi, where A represents the real value, B represents the coefficient of the imaginary value. So in the standard form here, that's what we were given. And number 14, when you added, Abby, what did you get?
I got 13 plus 24i.
13 plus 24i. How about number 16, Brandon? 11 plus 5i is correct. Number 18, it says to subtract, but we don't ever really subtract, Audrey. We So we change it to adding, and then we change the inverses, and when we add the inverse, we get
3 minus 2i.
3 negative 2i. Number 20, Maddie, when we subtract or add the inverse, we get?
Negative 6, negative 19.
Good, negative 6, negative 19i. How many got those first 4 homework problems all correct? All right, any questions at all? All right, let's continue then. And we had to multiply some complex numbers on numbers 28 and 30. And to multiply complex numbers, we simply do what, Genesis? Foil. And when we foil, of course, we have our first, which is the reals, our outer inner, which is real, imaginary, so it's going to come out to that imaginary value. And then when you multiply the last, that's imaginary times imaginary, which gives you that I squared, which is negative 1, which turns into a real, which combines with the real from the first. So what complex answer did we get for number 28?
40 plus 112i.
Say that one more time.
40 plus 112i.
Oh, I know what happened. You multiplied your first and you got a 48, correct? If you're kind of following through the work, your outer was a positive 120, your inner was a negative 8i, and that gave, or 120i and negative 8i, which gave you the positive 112i. The problem is when you multiply the last. What do you get when you multiply sign, number, letter?
Negative 20i squared.
There we go. We kind of treat it like a negative 2 and a positive 10 to get an 8, and should have gotten a negative 20i squared. Of course, we know I squared is really
Negative 1.
which when multiplied by negative 20 gives us
20.
positive 20. Then we can add the 20 to the 48 to get
60.
there we go, positive 112i. So it was right there, just a little careless there. How about number 30? What did you get on that one, Michael?
17 negative 51i.
Really close.
17 positive 53i.
Oh my. Brandon?
17 negative 59i.
17 negative 59i. Let's take a look at this real quick. Your outer is a negative 3i. Your inner is a negative 56i. And that's where we should get the negative 59i from the outer inner. We all got the 17 at least from the first and the last combining together. Questions on 28 or 30? Do any of us need to see the full problem 30 worked out? All right. And we get both 28 and 30 correct. You did a good job on both of those foil. All right, questions. All right, then going to number 32, we're dividing by an 8, and one could argue you could actually leave number 32 as it is. The text has you separate and divide once and divide twice. Well, if you divide once right here, class, that's going to give you negative 3. But you can't divide a 1i by 8, so you just leave it as a fraction. I over 8. Or 1/8 I would also work if you wanted to show the b as a separate coefficient. How many got that answer there, or the 1/8 I at the end? Any questions on that? An unusual problem there. Number 34, you can't leave an I in the denominator because what is I, class? Square root of negative 1. So since I represents a radical quantity, we can't leave I in the denominator. What's the best way to get rid of the I in that number 34 problem? Michael?
We found 34, divide it out. No, I multiplied by I.
Good. If you multiply by another I, that's going to give you an I squared, which is negative 1. But what you do to the bottom, got to do to the top. So just multiply top and bottom by I. Of course, in the top, you have to distribute that I, Michael, to get
69 negative 32i squared.
And in the denominator, of course, we would initially get
Negative 8i squared.
But we remember that each time we see an I squared, that's really just a negative 1. So this becomes
Positive 32.
and this becomes
Positive 8.
positive 8. And now we can just divide them by 8. Let's start with the real, so we get real before imaginary. 32 divided by 8.
4.
And 16i divided by 8.
2i.
Positive 2i. And there's our answer. How many have this answer for number 34? Questions on that? What to do with an imaginary value? Just multiply by another I, and that takes care of the I altogether. Question? Yes, ma'am.
I took the 8 out of everything.
Okay, so you started by knocking the 8 out to get a 2, negative 4i, negative, all over negative I? Nothing wrong with that at all. Again, we do have to take care of the I, though. So you could, I actually like that. Just let's get it out of the way and deal with smaller numbers. And then you could multiply the I. That give you a 2i, negative 4i squared. all over that negative I squared. There's your negative negative 1 or positive 1. And there's a negative 1 times negative 4 gives positive 4. And there's the same answer, though we flip-flop it to put real before imaginary. Does that make sense? So just got to multiply the I by another I in the bottom when that's all. It's not complex, just imaginary. Not sure what just happened up there. All right, questions on number 34. It's right over Audrey, though, so I'm safe. All right, questions on that one. Now we come to number 36, and Genesis, I like the way you were thinking on 34. What's also something we could do on 36? Take 2 out of everything to reduce it down to
3 minus 6 I and 7 plus I.
There we go. I like simplifying first. However, I can't just multiply by an I. Because if I did, yes, that would give you I squared here, but it would also give you a 7I, right? So I can't just multiply by I. Rather, when I have a complex number in the denominator, kind of what we said, we have to multiply by the conjugate. What is the conjugate of the denominator? 7 negative I, or 14 negative 2I if you didn't simplify first. But I'm a big fan of reducing first. And of course, in the numerator, we also have to multiply. Because once you do the bottom, you got to do to the top. In the denominator, really straightforward. It's a set of conjugates. It's a sum and difference. We do 3 things, class. Okay, well that's not particularly enthusiastic, but I think we mumbled it out. Square the first, square the last, put a minus sign between them. Kendall, when we square the first?
49.
When we square the last?
I squared.
And we, of course, put a...
Minus sign.
Well, we know I squared is going to become...
Negative 1.
And 49 minus negative 1 becomes plus positive 1, or just 50. In the numerator, though, inevitably we end up having to do what?
Foil.
More FOIL, right? First gives us
21.
the outer inner produces a... By the way, the FOIL's a lot easier now that we've reduced it down thanks to Genesis. I give a shout out to Genesis there. All right. She takes cash donations, by the way. Cash App, PayPal, she's got it all. What?
Negative 45I.
There we go, negative 45I. And then the last.
Negative 6I squared.
There we go. Of course, we know that the I squared, again, class is going to become negative 1. So negative 6I squared is going to become...
Positive.
It's positive.
Oh, careful. Yeah, okay, thank you. I was just, wait a second. Negative times negative. Yeah, it would be a positive 6I squared. Were you trying to catch that yourself?
Yeah.
I was like, she's saying something over there. I'm just ignoring. I'm going. All right, and so the I squared becomes negative 1. So this whole thing actually, class, becomes negative 6, which we can pair that with the 21 to get. 21 negative 6. 15. There we go. I knew I heard 15. Sounded like an 18 for a second. There's all negative 45I. And there's actually one more thing we could do to simplify again. We simplified at the outset. We can simplify again at the conclusion. Anyone? Take out a 5 to get what final answer? 3 negative 9I over 10. Or as the book would word it, 3/10 negative 9/10 I. I like that better, because I'm lazy. How many got that answer fully reduced? Let's see, anyone have... Let's see, we pulled out a 5 and we pulled out a 2 at the beginning, so it probably puts like a 10 in there, something like a 30 negative 90I over 100, anything like that. Okay. Questions at all on this problem? Yes, ma'am.
I got 17 minus 31I over 50.
That's sad.
For the
Did you take the 2 out at the beginning?
Yeah, but for the FOIL, I got 21 minus 31I minus 4.
Oh. Your outer's a negative 3I. The inner's a negative 42. You said you had a 31.
For the 3 minus 6, for some reason I have 3 minus 4I.
Gotcha. Okay. Oh, you pulled out a 2, but then for some reason your brain thought pulling out a 3.
Okay.
And that would be why. Okay. All right. So we found the mistake. That's the nice thing. Any other questions, comments on 36? Well, let's take a look at the last one that you had for homework. That was number 38. We have a negative 1, negative 9I. Again, it is okay to have leading negatives when you're dealing with complex numbers because you got to put the real before the imaginary. All being divided by 5 positive 2I. What do we got to do here, Genesis? Since we have 2 terms, one of which is imaginary, we got the full complex number.
Multiply top and bottom. 5 plus 2I. I mean 5 minus
Good. By the conjugate, 5 negative 2i in the top and in the bottom. And in that denominator, 3 things we're going to do, class.
Square the first, square the last,
Square the minus sign.
Yeah, it was a little louder mumble this time. And so when we square the first, square the last, put a minus sign, what do we get here, Genesis? Square the first,
20, 25,
square the last,
4i squared,
and put a,
minus sign,
of course we know I squared class becomes
negative 4.
times the negative 4. Genesis gives us a
4,
plus the 25, 29. So 29 is going to be the denominator here. That's not going to cancel with anything unless somehow there's a 29 in everything. That's highly unlikely. All right, let's come up here to the numerator and let's FOIL Maddie first. Outer, inner.
Negative 33.
Good job with those negatives. And then last,
18 squared.
18i squared. And that becomes a
Positive. No, I mean a negative 18.
good. Positive 18i squared becomes a negative 18. We can combine the negative 5, negative 18 to get.
Negative 23.
And we'll keep the negative 43i all over 29. And I believe those are all prime numbers. So nothing obviously is going to reduce, and that is the correct answer. How many had that for number 38? Any questions at all on the homework? We talked about imaginary numbers. Pull out your eye. We talked about complex numbers, a plus bi. Add them, just add, reals, imaginary. Subtract, add the inverse. Multiply, FOIL, divide. If it's complex, multiply by the conjugate. If it's imaginary, multiply an I. If it's real, just divide. Sign of a letter, sign of a letter. Questions? All right, now I told you we were going somewhere with all of this. We are in a chapter working equations, and somehow imaginary numbers just got shoved into the middle of the chapter. Well, that's because we couldn't do all we could do before. But now that we know imaginary and complex numbers, we can go a step further with some of these concepts that we've begun looking at in Algebra 1. Next section, your notes, quadratic equations, part 2. It's the sequel. Could call it Return of the Quadratic. Quadratic Strikes Back. Revenge of the Quadratic. Anyway, all kinds of different, or just quadratic equations, part 2. The Phantom Quadratic. Anyway. You notice I'm not dignifying 7, 8, or 9 with any mentions whatsoever. They don't deserve it. All right. So quadratic equations, part 2. How many Star Wars fans in here? All right, how many either don't even know what Star Wars is or really don't care and generally hate the mention of it?
Get out.
Okay, I'm sorry. See, this is the great thing about being a teacher is I can talk about whatever I want. So one day when you're the teacher, you can talk about your favorite movies. I like Star Wars. All right, that said, we're moving on. So the only thing you need to know for quadratic equations part 2 is write yourself a note that some solutions may be complex or imaginary. Some solutions may be complex or imaginary. I had to be very limited in the equations I could give you before. I had to make sure they didn't work out imaginary or complex. But now, I can give you whatever I want. You are now stronger with the force, so to speak, and therefore you are more prepared. Write this down if you would, please. X squared, positive 4x, positive 8. Equals 0. Such a sweet, innocent-looking little quadratic equation, right? But you know 8 and 1, 2 and 4 ain't giving you a 4, right? You know it's not going to factor. So you've got 2 options if it doesn't factor. You could
Use the equation.
Use the quadratic formula or
Imaginary.
complete the square. Either one. You either complete the, if you can't factor, you either complete the square or you use the formula. Now I've got a 1 right here and an even. So I look at this and I say, completing the square is going to be easy. That said, some of you may I just rather use the formula all the time. That's acceptable as well. But for practice sake, let's go ahead and complete the square here. Remember to complete the square, quick refresher, we ditch the constant. So we'll keep the x squared plus 4x, but my 8 moves over class and becomes negative 8. Then I fill in the blank. There are 2 things I do to fill in the gap, class. I half and square. We half and square, and when I half and square, class, I get 4. And if I put it on one side, I got to put it on the other side as well. So this x squared plus 4x plus 4 is a special trinomial. I made it special. I made it a, thank you, Maddie, a perfect square trinomial. And a perfect square trinomial class factors into a, my Algebra 1 students learned that yesterday. And what is the binomial here, class? X plus 2 quantity squared. And then on the other side, we got a negative 8, positive 4. That combines to give us a, and this is the first time we've seen one where it's negative. Because my next step is to take the square root of both sides. And we couldn't do that before. But now we can. We take the square root of x positive 2 quantity squared. Well, square root of x plus 2 squared is just x plus 2. And on the other side, what are the square roots of negative 4? 2 square roots, though. Positive negative 2i. Pull out your I. The square root of 4 is 2. Don't forget your positive negative 2i. Last thing we got to do is get the x by itself. And to get the x by itself, plus I've got to move the positive 2 over as a, normally I just put it at the tail end. But because we have to have real then imaginary, I'm going to write it as negative 2 plus or minus 2i. This means negative 2 plus 2i, negative 2 minus 2i. And there are my two complex roots. And there is no way to check this. Not really truly, not a good way to check it, let's put it that way. I guess you could. No, we're not going to. Especially technically you could, because squaring a binomial is multiplying by itself, and we know how to FOIL, we know how to distribute. No, let's just trust we did it right. All right, questions on that? I feel way too lazy to check. Write this one down. 3x squared positive 17 is equal to 2. What kind of quadratic do we have here? Incomplete. And with an incomplete quadratic class, we isolate the x squared. So what do I need to do here, Kendall?
You subtract the 17.
To get
Negative 15.
3x squared equals negative 15. Then, of course, I need to do what, Audrey? To get x squared equals. And then, Genesis, I need to. And, of course, the square root of x squared just becomes. But I'm looking at this square root of negative 5, and I'm thinking, class, pull out your I. And don't forget the positive negative. So what's our answer going to be here, Genesis? Careful. Pull out the I, but can I take the square root of a 5? So we'll just say positive negative I times the square root of 5. Here, you can take the square root of 4, hence the 2i. You can't take the square root of the 5, so just leave the square root of 5, but of course, pull out your I in both cases. Questions on this? 2 imaginary answers. 2 complex answers, 2 imaginary answers. Let's take a look at another one. Write this one down. 2x squared negative 5x positive 7 is equal to 0. I suppose it's possible you could put a 2 and a 7 together to work out a 5, except the signs have to be the same. So if you're thinking critically, you realize it isn't going to factor. I mean, maybe you take a shot at factoring. 2x and 1x, negative 7 and 1. But again, you got a negative 2x, negative 7x. Since the signs have to match, it's not giving you that negative 5. And when it doesn't factor, you have 2 choices, class. Complete the square or use the quadratic formula. Well, I don't want to complete the square. I ain't got a 1, and that ain't even. So I'm not doing that. I'm going to use the formula. Let's say the formula together, class. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is a? Maddie? B? And c. And we got to plug in those numbers. So for negative b, Brandon, we plug in
5.
plus or minus the square root of b squared
25.
minus 4 times a times c. Class 4 times a times c
56.
all over 2a. Notice the discriminant here, 25 minus 56 comes out to a negative 31. And we've said that anytime the discriminant comes out less than 0 or negative, my roots are going to be imaginary. Or maybe a better way to say it would be they're going to be complex. Because they do have a real portion, 5/4. That's real. But when I pull out my I to get 5 plus or minus I times the square root of 31 all over 4, that part's imaginary. So I get two technically complex, part imaginary. You weren't ready for that term yet though, but complex roots here. Questions on this one? Are we doing anything different with quadratic equations than we did before? No. You just may have to pull out your I every now and then when you get square roots and negatives. Make sense? Another thing that I didn't get to do everything we could have done before. Rational equations, part 2. Rational equations, part 2. Rational equations, class, are simply equations with fractions in them, right? And we hate fractions, so what do? Yeah, we'll multiply everything by the LCD. And we don't need to rewrite that in our notes. I think we have that down pretty well by now. But when I taught rational equations to you, you had not yet learned quadratic equations. So when we worked rational equations, they had to work out with one solution. Well, now you know how to solve quadratic equations. So here, just make this note that rational equations may become quadratic. These may become quadratic, and therefore you may have how many answers? 2. You may end up with 2 roots. Now here's where things get a little bit interesting. It is possible that of the 2 roots, one may be extraneous. Not guaranteed, but maybe extraneous. How will we know? All right, here's what we've got to do. Set all denominators unequal to 0. It's a fact of mathematics that you can never divide by 0. 3 divided by 0. Let's think about what this literally means. 3 divided by 0. Well, what if I said, what's 8 divided by 2, class? You would say it is 4. Here's a good way to think of it. Let's suppose I want to give Brandon, since he's my favorite student, I want to give Brandon $8. But I don't have $8. I have $2. So I give him $2. How many times will I have to give him $2 before he'll have the 8 I want to give him? 4 times. That's what division essentially is. Think about 3 divided by 0. I want to give Brandon $3 because he's my favorite student, but he's not as favorite as he was a second ago when I was giving him 8. And I don't have anything on me, so I give him nothing. How many times will I have to give him nothing before he'll have $3? I could keep giving you 0 infinitely. You'll never get those $3. But I can just keep giving you nothing. And he begins to question whether it's worth being my favorite student, right? You can't. You could argue this is infinite, but infinity is not defined. So we would say that anything divided by 0 is undefined. Perhaps a better way would be for you to ask Siri, what's 0 divided by 0? How many have done that? She gives the option about the cookies and you have no friends and it's, depressing and stuff like that. Okay. In general, anything divided by 0 is undefined. Denominators cannot equal 0. We know that. So when you set all denominators unequal to 0, it will show you a list of excluded values. To get excluded values. It is possible that in solving a rational equation that becomes quadratic, one of your roots may be on a list of excluded values. For instance, if I have a denominator somewhere that said x negative 5, well, I know that x class cannot equal 5, because that would give me a 0 denominator. We can't do that, right? Well, what if when I get my answers at the very end, I get x is equal to 5 and negative 7? We said x couldn't be 5. And here I'm saying x is 5. So you make a list of excluded values, and if one of your roots is on that no-no list, that's your extraneous root. That makes sense? That's not something we had to worry about before. We only ever got one answer. They were nice and simplistic. Again, it's not going to be hard. You know how to solve quadratics. Don't let this terrify you. But if a rational equation becomes quadratic, it's possible that you could get a root that would have been on a list of excluded values. We didn't see that before. It was not an issue before, but now it might be. Just got to make that list. For instance, write this down. Let's start with a proportion, because proportions are easy. We like proportions, right? We like proportions, don't we? Yeah. All right. Thank you, Michael, favorite student. All right, we have x minus 1 over x plus 2 all over, or equal to 2 over 4x. It's a proportion. It's nice and easy. And to solve proportions, class, we just, when we cross and multiply the means and the extremes, what do we get? Michael?
2x plus 4
There's the means.
is equal to 4x squared minus 4x.
Product of the extremes. So far, so good, right? And 4x squared.
Yeah.
I heard it and I didn't write it for some reason. All right. And we look at this and we're like, uh-oh, you didn't see any squares anywhere. On the surface, if I had to say, is that quadratic or not, I would say it doesn't appear to be quadratic. But as soon as you multiply, it is quadratic. So we got to set it equal to 0. Now let's put the 0 on the left-hand side here. And on the right-hand side, what am I going to wind up with, Brandon?
4x squared, negative 6x, negative 4.
There we go. We bring the 2x over as a negative to join the negative 4x. There's this negative 6x. The 4 over is a negative. Good job doing all of that mentally. I do want to help myself out just a little bit here, Abby. Yeah, to get it.
0 equals 2x squared negative 3x negative 2.
All right, and I don't know. I think it's worth a shot factoring this. Let's just see if this is factorable. If not, we'll go to the formula. I'm definitely not completing the square. 2x squared. How would I factor that, Genesis?
2x and x.
2x and x, and then the negative sign here, Kendall.
Different. So positive.
And the 2's gotta be, class, 2 and 1. Well, I wouldn't put the 2 with the other 2 though. So maybe 1 and 2. Okay. And let's check our outer inner. Does that give me a negative 3x? Okay, good. If it gave me a positive 3x, I changed the signs, but it worked out. So I'm going to set both of these, remember, both of these factors equal to 0. And I'm going to get two possible answers for x. My first answer for x, class, is going to be negative 1 over the 2. So negative a half. The other answer for x will be positive 2. We would expect two answers. It became a quadratic. However, there are two things x would not be able to equal right off the bat. X would not be allowed to equal negative 2, nor could x equal 0/4, which is 0. For instance, 0 divided by 4, that's just 0. For instance, if Maddie's not my favorite student, I ain't giving her nothing. How many times can I give her $4 before she'll have nothing? I can't even give it to her once, or else I've given her stuff, right? So 0 divided by anything is 0. Anything divided by 0 is undefined. Well, there's the two things x couldn't equal. Couldn't be a negative 2 or a 0. Do I run into any conflicts down here? No. So, it became quadratic, and I got my two roots. I didn't happen to get an extraneous root this time, but we want to check for it. Does that make sense? Let's do another one. Write this one down. Let's do another whatever it's called, proportion. Let's do 5 over an x squared negative 4. And let's say that that's equal to 2 over, let's go with an x squared positive x negative 6. Now here, I can already see that it's quadratic. Would you agree? But it's still a proportion, so I just cross multiply. Kendall?
2x squared minus 8 equals 5x squared positive 5x negative 30.
That is a 5, not an S. It just didn't look much like a 5. And what kind of quadratic do we have here, Audrey?
Complete.
So I need to.
So you can put 0.
And which side is 0?
The right. Well,
I could. I wouldn't, but I could. What do we get?
7x.
Oh. Ooh. If I bring this over, it becomes
Negative 3x squared. Negative 5x. Positive 22.
And right off the bat, I don't like the fact that there's a leading negative, which is why I would have moved everything over, but it's not actually that big a deal, Audrey. I can just,
Switch the signs.
including this sign, but 0 doesn't have one, but again, if there was a sign on the other side, I'd change that too. And then it's positive again. So again, if you just really like having everything over on the left-hand side, you can still move it there. Just make sure we change the signs if you wind up with a negative. Do you want to take a shot at factoring, or we just want to go with the formula? I've got people telling me it factors, okay, because they work ahead. And so the 3x squared,
3x minus 11.
and 3x and x, right? And then the negative sign,
Negative, positive.
negative, positive, and then the 22's got to be
11, 2.
11 and 2, 2 and 11. Let's try 11 and 2 because that's what he said. And
Changes.
yeah, I'm coming up with a negative 5, but that's no big deal. I just changed the signs. And now I'm coming up with a positive 5x I wanted. So that's going to give me two answers for x. What are the two solutions possible for x here, Genesis?
Negative 11 and 2.
Well, careful, also divide the 3. So move the 11 over as a negative, then divide the 3 to get negative 11 thirds, and then also
Positive 2.
a positive 2. But before you circle that as your answer, let's go back up here and see what kind of things x wasn't allowed to equal to begin with. For instance, x squared negative 4 couldn't equal 0, which means x squared class could not equal 4, which means x could not be either
Positive, negative 4.
positive or negative 2. Does anyone see a problem with that?
Yes.
I said that x was equal to 2. It's not allowed to. From the outset, it wasn't allowed to equal to 2. So we've got to disregard that value. That means probably this one's okay. Right, because usually at least one of them works, but we could check, right? X squared, positive x, negative 6, unequal to 0. And of course, this looks like it factors to me at least. X squared, x and x signs, positive, negative 6. Put the 3 with the positive, the 2 with the negative, so outer inner gives you the positive x. So x could not equal.
Negative 3 is
Well, we already said x couldn't be 2, so we took care of that. And then negative 3 is the only other value x couldn't equal. Negative 11 thirds is fine. There's my only root. That one's extraneous. Questions on this? Obviously, hadn't really seen this before. Questions on this? All right. Turn in your textbooks, if you would, please, to page 111. Page 111. And I want you to do number 21. Let's do 21 to 24. 21 through 24. They're at the bottom of page 111. Practicing with the quadratics. know. Just making sure you're awake. Thank you. You're welcome. Yeah, I'm not seeing a factor in here, and definitely not wanting to complete the square. Yes, there we go. All right. So we check your answer, number 21. How many good on 21? No problem on 21. -5 plus or minus I squared of 47 all over 9. Anyone maybe leave it here? -10 plus or minus I squared of 188 over 18. Now look at those last two digits. I knew there was a 4 in there at least because 88 is divisible by 4. So I got the 4 in 47. That's where I got the 2 from the 4. And there was a 2 I could cancel out of everything. But if you at least got this far, you just had to look for the reducing step. Questions there? Any questions at all? 21. All right, keep working. Those who finished with 22, check your answers on 22. Somebody got the -3 plus or minus I squared of 5 over 2. All right, anyone stop here at the -6 plus or minus I squared of 20 over 4? Again, look for the reducing. 4 and 5 gives you a 2 square root of 5, and then we can cancel the 2 out. Number 23, this shouldn't have been real hard. How do I write my equation for 23, Abby?
2q squared plus 5q equals -2.
There we go. And again, we want to bring that over as a positive a equal to 0 so we can get our A, B, and C. And by the way, if they're all positive, that's usually not a good sign for coming up with rational answers. What is it? -5 plus or minus square root of 25 minus 64 all over 4. 25 minus 64.
39.
-39. So -5 plus or minus I times the square root of 39 over 4. Not pretty, but it is correct. I'm going to have this for 23. All right, questions on 23. Number 24, how do I write my equation genesis? The difference between 3r squared and 3r is 2.
3r squared minus 3r equals 2.
There we go. And I'm going to send the 2 over since it was equals 2 plus. Let's bring the 2 over as a -2 equal to 0. At this point, I'm not trusting anything but the formula. So we go with the 3 and -3 and 2 for my A, B, and C. So that's negative B becomes a positive 3 plus or minus square root of 9 minus 4AC becomes what, a 24? Yeah, all over 6. That becomes
33.
Oh, 9 negative 24? Yeah, -15. And of course we have to pull out the I. Can I cancel something out of the 3, 6, and 15 class?
No.
Is it -3, 2 for C?
No.
That's why I have 33.
Yeah, let's go with -2 then. And thank you. Yeah, we brought it over as a -2. Thank you. So that would be -4 times 3 times -2 would be positive 24. Thank you. And show off. And no, I'm glad you were paying attention. And now can I cancel a 3 out of everything? No, because I still can't cancel a 3 out of a radical. No I to pull out. This time it's not imaginary. It's just irrational. Anyone make it that far? Get that for 24. I know some of you made it that far. Questions on the ones we got to? Questions on the ones we got to? All right, look quickly with me at page 116. Page 116. And for sake of time, let's just look at number 22. Number 22 at the top of page 116. How would I write that equation? Michael?
Y squared minus 9 over y squared plus 3y minus 18.
Say that one more time?
Is it quotient means division, right?
Yes.
Okay. So it's y squared negative 9 over y squared plus 3y minus 18 equals 7.
There we go. Okay, yeah, I don't know if you changed what you said or if I just didn't hear you correctly. But good. Y squared negative 9 over y squared positive 3y negative 18 all equal to 7, which if I put the 7 over 1, I have a proportion, and I can cross multiply. What do we get when we multiply the means together here? Audrey?
Y squared minus,
That's the extremes.
y squared, 7y squared, plus 21y, negative 126.
Hey, all without a calculator. Great job. And then, of course, the extremes class.
7y
The extremes.
y squared minus 9.
Y squared negative 9. Remember the first and last of the extremes. And let's set it equal to 0. Bring the y squared over as a negative to get.
6y squared.
Let's leave the positive 21y. Let's bring the 9 over as a positive 9. Anyone?
117.
Negative 117. Anything we could do to simplify our lives here? Take out a 3. Good, Maddie. We know these two are divisible by 3. Add up the digits. That's a 9. What do we get if we pull a 3 out of everything, Maddie?
2, 3. Positive 7y, negative 39.
Good job there. And do we want to try to factor this? 30. I think we can. Let's give this a try real quick. The 2y squared would have to be, class, 2y and y. Signs would have to be different, right? Positive, negative. How should we try to split up that 39? 13 and 3. And check your outer inner. Yeah, it works out. So we could say that y is equal to 3 and negative 13 halves. Let me end real quick with this though. But anytime a rational equation leads to a quadratic, we better set the denominators unequal to 0. Do we really need to say that 1 doesn't equal 0? Of course, of course not. But here we do need to say that y squared positive 3y negative 18 does not equal 0. Help me quickly with this. What should we do to determine our unequal values? Let's backwards FOIL here, right? Split up the y squared into y and y, negative sign. The 18,
6 and 30.
positive 6, negative 3, so the outer inner check. So what two things can y not equal? Negative 6 and positive 3. Do we have issues with any of those?
Yes.
We do have an issue with 3. So let's take that out. Y only equals negative 13 halves. You're going to practice with just 5 problems this evening for homework. Page 105. Numbers 39, 40, and 43. Page 105, numbers 39, 40, and 43. And then on page 110, do numbers 18 and 20. Page 110, do numbers 18 and 20. Take a look at those in our next lesson. Have a wonderful rest of your day, and you are dismissed.